We're going to do number 2 now, and what number 2 is asking you to do is use both the trapezoidal and the Simpson's rule to approximate the area underneath this curve. So really you're just going to be using those two different formulas that they gave you in this textbook. And I do have them off to the side here, and I did encourage you in the short lesson that you really should look over page 444 and see how they came up with the trapezoidal rule, why it works, because I really do believe that you can follow that algebra. So if you take a while to figure out why it really truly works, you will look at this as not so foreign anymore. Okay, so I'm just going to really show you how to plug and chug away with these formulas on the test. You won't be expected to memorize them, but I would give you this formula on the test. So if I ever ask you to approximate the area underneath the function by the trapezoidal rule, you will have this available to you, but you will be responsible for knowing what each one of these pieces mean. Okay, so back to the problem. Okay, so I have gone ahead and graphed this number 2. They gave me this. And so what I do know I'm trying to do is approximate the area from 0 to 1 underneath that's bounded by this function right here. So I graphed that function in orange, and then I also kind of just divvied up, or I sectioned off the area from 0 to 1 that I'm interested in. The next line of business is that I'm going to have to separate this into 4 equal pieces. So I'm going to go ahead and do that. Here is from 0 to 1. Alright, and I'm going to separate this into 4 equal pieces. So on this line, I'm going to just show this off to the side. It's kind of a blown up picture of that area underneath that curve. So this is that area drawn here, and what I've done is I've separated it into these sections. So really what you're drawing is these lines, and these form what we're kind of drawing and sketching in as trapezoids. They're closer than the rectangle approximation that we did before with these exact rectangular shapes. So what I'm going to say is this is x sub 0, x sub 1, x sub 2, x sub 3, and x sub 4. And so those are part of that equation, because what I'm going to be using is b minus a, so in other words 1 minus 0. So all of this is approximately equal to, by the trapezoidal rule, if you just plug and chug with that formula, you have 1 minus 0 all over 2 times, and then we got this 4. That's what we said n was equal to. We're sectioning this interval into 4 equal pieces. So 2 times 4. Alright, and then what we have to do is we're going to have to take, I'm going to leave some space here, but we have to have f of from x sub 0 all the way up until x sub 4. So I'm going to need a plus, and then I'm going to leave a blank here, or a little space, and you'll see why in a second. X sub 1 plus, I'm going to leave another space, x sub 2, f of x sub 2, plus, I ran out of room, so I'm going to go to the next kind of line here, x, and then all the way up to, this would be my last term because I've made it to the x sub 4. Okay, and then going back off of that formula that they gave us, how you would read this is when you set this up, you want to go from however many n values that you were given, from x sub 0 all the way up to f of x sub n, and then everything in between except for the 2 ones at the end. So f of x sub 0 and f of x sub n is disincluded from this, but you want to multiply it by 2. And once again, look over page 444 to see why that is. So I'm going to go ahead and do that. Here's my 2. Here's my 2. And I also need a 2 in front of my f of x sub 3. Okay, so now what exactly are these x sub I values? Well, x sub i's are going to be equal to your delta x times whatever I you're interested into. So we have seen this before. When you're looking at this, we called this C sub I in the past when we were doing the approximation of rectangles. But when you're looking at the subsections, what we did was understand that each one of these little increments from x sub 0 to x sub 1, this is what we would call delta x. So delta x, it's the width of these trapezoids, and delta x. Okay, so at this point right here, we don't want any delta x. X sub 0, the x value on this x-axis would just be 0. Here though, what is delta x? Because we want one of them. X sub 1 would be 1 delta x. x sub 2 would be 2 delta x's. X sub 3 would be 3 delta x's, and x sub 4 would be 4 delta x's. So x sub I would be given by this equation right here. You do have to be careful of this. I highly recommend that you draw sketches like I have done here. What I'm going to go ahead and do is calculate what is delta x. Once again, that will be given by your b minus a all over n. So it would be 1 minus 0 over 4, so 0.25 is what I'm going to say. Okay, and so now here's the thing, x sub 0 would just be delta x times I. So it's going to be 0.25 times I, which is in this case 0, so 0. X sub 1 would be 0.25 because it'd be delta x times 1. X sub 2 is going to be equal to 0.25 times 2, so x 0.5, and you would even see that on this x-axis. You can see that clearly. X sub 3 is going to be equal to 0.75, and then finally x sub 4 is going to be equal to just 1. Okay, so I do have to move this down, unfortunately. Okay, so I am going to be using this once again, but now I can plug in these x sub 1s, x sub 2s, x sub 0s, all of those. So I'm going to simplify this. We get 1 over 8. We have 1 over 8 times f of, and then 0, plus 2 times f of 0.25, plus 2 times f of 0.5, plus 2 times f of, 0.75, and then plus f of 1. So I have just rewritten this right here with all those filled in. Now what I'm going to do is, this just requires now for you to go back to what your function is. So here was our function. It's this x squared over 2 plus 1. So what you're going to have to do is plug in, well, what is 0 squared divided by 2 plus 1? That first piece right here is going to be 1/8 times f of 0, which when you plug that into your function, it's going to be 1, plus 2 times, when you plug in 0.25 into this equation, and then try it on your calculator, but what you're going to have is, actually I'm sorry, when I did this ahead of time, what I did was I calculated 2 times f of x sub 1, so I plugged in 0.25 into our function. What I got was some number, and then I multiplied it by 2, and so what I got total, 2 times with that 0.25 plugged into here, I got 2.065 plus, and then when I plugged in 0.5 into this equation, calculated that out, 0.5 squared divided by 2 plus 1, and then I multiplied it by 2. What I got was 2.25 plus, and then this was my f of 0.75. When I took that and multiplied it by 2, I got 2.5625, and then plus f of 1, I plugged in 1 up here, 1 squared divided by 2 plus 1, I got 1.5. Okay, and so these really just kind of come down to being somewhat tedious, but when you add all of these through and then multiply it by 1/8, what you will get is approximately, by this trapezoidal formula, 1.171875. And I went ahead and did the fundamental theorem of calculus on here. So in order to actually calculate this, once again I have from 0 to 1, I had x squared divided by 2 plus 1 dx. So I went ahead and differentiated this. So I added 1 to the exponent, and then so therefore I had to divide all this. So I got x to the third divided by 6 plus, and then 1x. And then this is that notation that you do, 1 over 0. And so when I went ahead and calculated this out, what I had to do was plug in 1. So 1 cubed divided by 6 plus 1 minus, and then what I had to do was 0 cubed over 6 plus 1 times 0. So this is big F of 0. This is big F of 1. And then what it just comes down to is 1, 6 plus 1. So 1.16 repeating. So this is the exact area using the fundamental theorem of calculus. But this right here was an approximation using trapezoids, and this was very, very close. I want to set you up. I'm not going to actually go over how to do the Simpson's rule. That's in the next video down below. But I do want to set you up with number 7. Okay, so we had this 4 to 9 of the square root of x dx, and they let n equal 8. So this is by far a very... Okay, for number 7, I need you to be very careful when you graph this. So I'm going to draw a very rough sketch of this. But you're going to have something like this. Alright, there is your x squared function. And this is a good example actually, because this is something that's not easily never mind. So what you would have is 1, 2, 3, 4, 5, 6, 7, 8, 9. And what we're actually looking for is the area bounded by from 4 to 9. So you're going to be making all these trapezoids within this region. And you're going to divide this into 8 equal pieces. So I'm going to divide this in half, and then I'm going to divide that in half, and then I'm going to divide that. And then I'm going to divide this in half, and I'm going to divide that. So what you have to realize is this is your x sub 0, this is your x sub 1, x sub 2, x sub 3, x sub 4, and this one's just tedious more than anything. Sorry, x sub 5, I ran out of room, x sub 6, x sub 7, and this is x sub 7, and this would be x sub 8. Sorry, this is very messy, but I just want to be able to get you set up. So when you do figure out, you're going to need all of these f of x sub 1, zeros, x sub 1, x sub 2. X sub 0 in this case, you have to be careful because it's not any longer just delta x times I. This right here is actually going to be 4 plus delta x times I. Okay, so nothing really has changed except for your x sub i's are going to have to be given by not just delta x times I, but you'll notice this very first one will be 4 plus delta x times I. So all of these are delta x's, and so your next one over, this next x sub I, so along the x-axis, you would have to say, all right, it would be 4 plus 1 times delta x, and then 4 plus 2 times delta x for your x sub 2, and then 4 plus x sub delta x times 3. So when you're moving along this x-axis, all of your x sub i's would be given by 4 times delta x times, in this case, 0. This one would be given by 4 plus 1 delta x, so 1 times delta x. This one right here, this x sub 2, would be given by 4 and then plus delta x times 2, because there's 2 delta x's. This is 3 delta x's, and so you would add that to the 4. So this is what you're going to use for your x sub i's. It'd be 4 plus and then delta x, and once again delta x is just going to be given by 9 minus 4 all over n, which we said is 8. So you are going to have kind of a goofy fraction here. We're going to have 5/8. So 5/8 times 0 is just 0, so we got 4. X sub 1, so just getting you started, and then you're going to have to plug this into your other equation. We would have 4 plus delta x, which is 5/8 times 1, just leave that at that. X sub 2 would be 4 plus delta x times 2, so it would be 10/8, which would be 5/4, and you could simplify these out, but I wanted to get you started in how you determine your x sub i's. Alright, so look down at the video below. That's someone else on YouTube that I found, but I think he gave a very good explanation as how to use the Simpson rule. Alright, thanks.